So many students get this problem wrong, so don't be the one that gets it wrong. So let's walk through it together. So when you see it on your exam, you can get it right. Okay, we have this fluoromethylcyclohexane here. It's got potassium butoxide, um, or tert propoxide actually, not terpropoxide, isopropoxide, in 2-propanol, also isopropanol, and it is in 97 degrees C, so heat. So we have strong bulky base, protic solvent, heat, that's going E2. We need to figure out what is our leaving group right here. So we're going to form our double bond here or here. Now, a lot of people is where they get messed up. They think the double bond forms here because they're looking for that Zeit product. You're going to form your most substituted double bond. But what actually forms is this. The double bond forms right here. And I'm going to draw it in a chair still because I know the bonds won't be perfectly correct, but I'm not worried about bond angles right there right now. So if you are worried about bond angles, you've been forewarned that right now I'm drawing this without very good bond angles. So that's a terrible chair confirmation. Actually, I'm going to make this thicker. There we go. There we go. We're going to have our, actually, I don't like that either. Air confirmation is such a pain in the ass to draw. There we go. I'm going to put my double bond right here. So our double bond goes right there. We have a methyl over here. Now, why is that? This is our correct answer. And so you could draw it like this and give that some stereochemistry. And that's because, remember, for E2, we need an anti-periplanar hydrogen. The hydrogen over here is actually be equatorial down. I just drew equatorial up. It's equatorial down. This is not at a 180-degree angle, but there's over here we have an axial up, equatorial down, right? So if we draw the Newman projection of this, if we're looking down this way, the Newman projection looks like this, where we have our chlorine down, goes to our ring, and behind it, we have our CH3. I have the proton out here. These are anti, that can't participate in our E2 reaction. But if we look down this bond here, we have chlorine out to the rest of the ring. We have our proton. And behind it, we have our axial up hydrogen, which is anti, and then we have the rest of our ring. So now we have our anti-hydrogen, and that participates in it. So this one trips up a lot of people, so make sure it's not you.